Hi, everybody. Let's take a look at an example of a variation of a cosine graph. In this example, we'll plot the function y equals -4 cosine of 2x minus pi over 2. So the general form of the variations of a cosine function is y equals a cosine of bx minus c plus d. In our example, a is -4. The absolute value of a is the amplitude. So that means this function will have an amplitude of 4, meaning its peaks and valleys will have a distance of 4 from the axis that we're plotting on. B equals 2. That means that the period is 2 pi over 2. We use 2 pi in the numerator here because that is the period of the regular just cosine x function. So our period for this example is pi. C is pi over 2. So our phase shift, we calculate using C divided by B. So pi over 2 over 2, which is pi over 4. I also call this the starting point. This is going to be the first of our 5 key points. And D equals 0, so we don't have a vertical shift for this function at all, meaning we will be plotting just on the x-axis. So to summarize, this function has amplitude 4. We're pi periodic, and we're going to start at pi over 4. That's going to be our starting point. Take the starting point and call it x1. We're going to successively add by the period divided by 4. So our period in this example was pi, and divide that by 4. That's how we're going to add successively to get all of our 5 key points. It's a coincidence in this example that the starting point and the period divided by 4 are the same value. So x1 is our starting point, pi over 4. So that means that x2 will be calculated by doing pi over 4 plus pi over 4 to get to pi over 2. x3 will be pi over 2 plus pi over 4, again, to get us 3 pi over 4. x4, take x3, add pi over 4 to it, that'll give you pi. And x5 is pi plus pi over 4. That's 5 pi over 4. Now, these values are 5 key points. When you plug them into the function, we're going to get the quadrantal angles. We're going to get 0, pi over 2, pi, 3 pi over 2, and 2 pi, which makes cosine very easy to evaluate. And let's just confirm that by taking a look at a few of these points. So if we plug in pi over 4, for example, then in this function, we will have -4 cosine of 2 times pi over 4 minus pi over 2. Now, 2 times pi over 4, that's pi over 2. So that's how the inside will simplify to 0, and cosine of 0 is 1. So -4 times 1 is the function evaluation at pi over 4. So right away, we know we have a point at pi over 4, comma, -4. That's one of the coordinate pairs on this graph. And you can keep working through and comparing the values in this table and how they'll simplify to quadrantal angle inputs. So cosine at pi over 2 is 0. That's how -4 times 0, that gives us this value here for the coordinate pair associated with the input pi over 2. Continuing in that fashion, we'll find that at 3 pi over 4, this function is -4 cosine pi, which is 4. Cosine of pi is -1, so we have -4 times -1, which is 4. At pi, this function will have its input simplified to 3 pi over 2, and cosine at 3 pi over 2 is again 0. And then finally at 5 pi over 4, the input will simplify to 2 pi, so we're already a full circle rotation around. We should get the same value as what we got in the very beginning, -4. And cosine of 2 pi is, of course, 1. So -4 times 1 is giving us that -4. Now, take these 5 coordinate pairs and plot them on a graph. At at pi over 4, this function evaluation is -4. At pi over 2, this function is 0. At 3 pi over 4, recall that we were up at 4. At pi, we had another 0, and at 5 pi over 4, we're down here at -4. And now, you can fit those points with a curve, and then by inputting a few more values, you can extrapolate this behavior. So plug in, for example, 0. The input will simplify to just negative pi over 2, which is where cosine is 0. So we're going to have a point at 0, 0 on this function. And if you plug in a few more values, you'll get this picture. And you can just extrapolate the behavior that you got from one of the periods and draw a picture like we have here with many periods of this function. Thanks for watching, everybody.